Hello everyone, my name is ERINA BINTI, usually be called by ERINA, and today I will present about the sport technology under winter sport, which is ice hockey. Hello everyone, my name is ERINA BINTI. Okay, let's move on about ice hockey. Ice hockey is a game that plays on the low friction ice surface and involving high impact collision, so that material plays a very crucial role in ensuring the performance, safety and comfort for the athlete. Let's begin about the material and mechanical requirement. So the first one, it will be helmets and protective padding. For the material, rigid but flexible outer shell that will be made from the thermoplastic like a nylon, often reinforced with materials such as fiberglass. For the inner padding, is typically shock absorbent vinyl nitrile foam or specially formed, which harden instantaneously, upon high rate impact to disperse energy. For the mechanical requirement, high impact resistance and shock absorption to prevent the concussion, fractures and bruises. The feet must be snug and secure without hindering the movement of the athlete. The second one will be stick. For the material, modern sticks are predominantly made for the lightweight carbon fiber composite or graphite. Regarding the traditional stick, use hardwood like hemp or birch. For the mechanical requirement, research engineering for the optimal flex or stiffness and elastic energy storage for release for powerful shocks while maintaining the durability and a consistent feel. Different flex profiles are available for the different players' position and shot types. The third one, we will talk about the skate. For the material, the boot consists of a rigid outer shell that made from the molded plastic, synthetic leather, or thermoform composite materials, often with memory foam for a custom fit. Blades are typically high-quality stainless steel or carbon steel for the edge retention. Regarding the mechanical requirement for skates, it needs to be high rigidity for angle support and force transfer, which is energy efficiency with resistance to cuts from other skate blade. The blade design allows for both a low friction gliding and high friction push-off. And the last one, it will be puck. For the material, solid disc of vulcanized rubber with added carbon black for color and property enhancements. For the mechanical requirement, cross-distance hardness and elasticity and tear resistance across a range of temperature, -6°C to -9°C. Then let's move on about the critical properties. The first one, it will be the puck. The puck made from the vulcanized rubber. It needs to have the higher hardness and higher density, high enough to withstand the slap shot speeds of 100 plus mph without shattering, but dense enough to stay on the ice. For the second one, coefficient of restitution, achieved by the freezing the puck. This reduces bounce to ensure it sticks to the player blade and stay flat. The third one, it will be thermostability. It needs to maintain its shape and weight at the sub-zero temperature without becoming brittle or soft. For the second one, we will talk about the ice that made from the purified water. Dynamic hardness, maintained at -4°C to the -6°C. It must be hard enough to allow fast gliding, but soft enough for skate blades to bite for turning and stopping. And the second, for the ice, the surface friction, extremely low coefficient of friction to allow the puck and skate to glide with minimal energy loss. And the last one will be compressive strength. Must support the localized high pressure of a thin metal skates blade and carrying a 200 lb player without collapsing. Let's continue. The third one, the stick, made from carbon fiber composite. Flexibility, the ability to store elastic potential energy when bent against the ice, which is released to whip the puck forward. The second one, strength to weight ratio, extremely high, must be light enough for one-handed handling, but strong enough to survive the splashing impact. Then third one is vibration dampening. The material must absorb shock, so the player can feel the puck through their glove without painful vibration. And the last one, for the critical property, we will talk about the protective gear, made by the polycarbonate and high-density foam. The first one, obviously impact resistant. Helmet made from the polycarbonate must have high fracture toughness to stop high-velocity puck without cracking. And the second one, energy absorption. Internal foam must have high viscoelasticity to disperse the force of a collision of a larger surface area and time. Let's continue about talking the benefit of material for the performance, safety and comfort for the athlete. The first one, stick, made from carbon fiber. Carbon fiber have the high flex so that it can store energy for weight and fast discharge. Regarding the safety and comfort, you have the damping, absorb vibration to prevent hand fatigue. The second one, skate blade, that can be made from the stainless steel. Stainless steel is very hard, so it can hold a sharp edge for tight turns. And regarding the reliability, high fracture toughness, avoid mid-game snaps. The third one, helmet, made from the polycarbonate or EPP. EPP have the lightweight so that it reduces net strain during the play. For the safety and comfort, it have impact dispersion. Foam partials to absorb brain rating force. And the fourth one, skate boot, made from the thermoplastic. Thermoplastic have a power transfer so that it can transfer the stiff wall, ensure no energy is lost. And for the safety, heat moldable, bakes to the foot, shaped for the zero blister. And the last one, we will talk about sock that usually made from the Kevlar or ballistic nylon that have high flexibility so that it can allow for foot strike extension. Ready for the comfort, it has cut resistance so that it can protect against sharp skate blade lacerations. For the third question, it asks for suggest one suitable material for the application of chosen sports. So in my opinion, carbon fiber reinforced polymer CFRP is the best material for ice hockey. Let's talk about the its structure. It have thin high-strength carbon filaments, which is crystalline carbon atoms that are embedded in an apensine resin matrix. It's also, the fibers are layered in specific orientation to handle multi-directional stresses. Regarding further properties, it has high specific strength, so it offers a massive strength to a weight ratio. It's lighter than wood, but can withstand higher force. For the elasticity and flex, it has high elastic potential energy, allowing the stick to load like a spring and snap back to its original shape instantly. Third, a proficiency aspect. It compresses more than. So, it means that pre-printed layer are wrapped around a metal or air bladder and placed in the heated mold. The last question asking about what is the future material trends in ice hockey. So my answer will be the first one, bio-based resin. Moving away from the petroleum-based epoxy, future sticks and skate will utilize bioresins, recycle carbon fiber to reduce the carbon footprint to have the higher performance gear. And the second one, recyclability. Manufacturers are developing thermoplastic composite that can be melted down and reformed, addressing the current issue where broken carbon fiber stick end up in landfill. The last one, auxiliary structure. Future padding will use auxiliary form that thicken when stretched, providing superior shock absorption during high-speed part impact or collisions. So, in conclusion, modern ice hockey gear use advanced material to balance protection from high-speed impact with the athlete need for the motion. Using carbon fiber and shock-absorbent foam allow for the equipment that is lightweight for performance, yet strong enough for safety. Looking ahead, sport engineering will focus on sustainability and technology. These include developing eco-friendly material and using smart sensors to track performance and player safety. That's all from me. Thank you.